Oh my, oh man, life is so hard. So hard. So what do you think u is going to be?
X squared plus 1.
That's a good call. It's a good pick because when you take the derivative, you're going to end up with something that has a degree that's one less than what you started with, which is kind of what you want because you're trying to cancel something that's just x. So you make the substitution, what do you end up with? X over u squared times du over. What's the happy thing that happens? It goes away. So you end up with 1/2 u to the negative 2 du. So you end up with 1/2 u to the, 1/2 times u to the negative 1. But what do you have to put up front? Negative. So you end up with negative 1/2 u to the negative 1 plus c. So which turns into negative 1/2 times x squared plus 1 to the negative 1 plus c. I'm sensing some hesitation there. What was the mistake? Or what wall did you run into? What?
Like trying to bring the bottom up and then make it negative.
Yeah. Got really stuck? Sure. Just be careful. So what do you think u should be? What did you think u should be? That's a great thing to start with there, Camille. How about u is equal to cosine x? Because if u is equal to cosine x, you end up with, what do you end up with? Sine x dx. So what does dx equal? Du over sine x. So what do you end up with? Sine x over 1 plus u squared times, put the negative on the outside, du over sine x. Again, what's the happy thing that happens? Yay, the sine x is gone, leaving you with this very friendly thing because I asked you all about this. What is that? That's the derivative of what?
Tangent.
Tangent inverse. Oh, look at that. Tan inverse of u plus c. Remember I asked you about that stuff? It's right there in front of you. If you don't see that, you're not going to see it. There's no way, kids, you are not going to have time, nor will you really remember how to prove this relationship. You just have to know it. You have to recognize 1 plus 1 over u squared is the derivative of inverse tangent. So what's the final answer? Negative tangent inverse of cosine x plus c. No, they'll take both. That's totally fine. So what did you think u should be? What do you think u should be? The radicand, right? ax squared plus 2bx plus c. Because you end up with du is equal to 2ax dx plus 2b dx. So du is equal to 2ax plus 2b dx. So dx is equal to du over 2ax plus 2b, which is the same thing really as du over 2 times ax plus b. So now you get to substitute nicely with ax plus b over the square root of u times du over 2ax plus b. What cancels on, which is the happy step? Here's your happy step. It's gone. What gets pushed out? Half. And you're left with u to the negative 1/2 du. Now, is it just a matter of integrating and substituting back in? Yeah. I'm not going to finish it here, but it's just a matter of integrating something that's pretty straightforward, decently straightforward, and plugging this back in. Well, let's just try evaluating and see what happens. On this first one, this is the integral from what to what? 0 to 1 of what function? E to the root x times what? Dx. So let's actually try evaluating it and see what happens. What do we think u should be? Yeah, let's do u as root x. So du is going to be 1/2 x to the negative 1/2 dx. So what does dx equal? 2 du times x to the 1/2. So we substitute in. We have a different, now we have u is equal to the square root of x. So what does that change the limits of integration to? What's the square root of 0? What's the square root of 1? So it actually changes it to the same thing. It doesn't change it. Do you see? Remember, we're going, those are x values. Now we're in u. So now what do we have here? E to the what? U times, instead of du, you have 2 du x to the 1/2. What can we factor out to the outside? 2. So you have 2, 0 to 1 of e to the u times du x to the 1/2. What does x to the 1/2 equal? Look at this, everybody. What does x to the 1/2 equal? U. So what do you actually have right here? 2 times 0 to 1 of u e to the u du. That is entirely written in what variable? Yeah. So theoretically, maybe we think to ourselves, we can integrate that. But you might get a little frustrated, and you might give up. I will tell you right now that we've gone about as far as we can go using this method. So if you got stuck here, what would be the next thing you should do on this problem if you got stuck here? Do the next one. Let's see what happens. Let's do the next one. So this integral is what? The integral from 0 to 1 of 2x e to the x dx. What can you factor out? 2 times 0 to 1 of x e to the x dx. Does that look familiar? What is this? This is the exact same thing as this. Does it matter that it's called u and x? Not at all. It doesn't matter what you call the variable. It's the same value. So for example, if I asked you, if I gave you y squared, sorry, hold on. If I gave you y squared and x squared, and I said, you're plugging in 3 into each one of them, they're the same thing. X and y are arbitrary labels. Way back when axes were first used, could they have been called the q and z axes? It's arbitrary. So the other way to think about it, if you wanted to, what substitution could you make to turn that into u? U equals x. And guess what you end up with? The exact same thing. So what can you say about the first two? They all equal each other? Maybe. In this case, this is the integral from 0 to what? Pi over 2. And what do we want u to be, do you think? Sine x. So what does du equal? Cosine x dx. Does that sound good? Okay. So now, instead of 0 to a pi over 2, what do we have? Well, excuse me. We can do this out if we want to, but I'm not. Let's just write it out. 0 to pi over 2 of e to the sine x times sine of 2x dx. We're now doing the u substitution. So what do we now have? What's the limit of integration become? What's sine of 0? What's sine of 0? Kids, AP Calculus, be more confident in your answers. 0. What's sine of pi over 2? 1. 1. Okay, we need to be a little bit more knowledgeable in trig land, okay? Okay, so now we have e to the what? Sine of 2x. And what does dx equal? Du over what? Cosine x. Okay, so now you might be a little stuck, but then you guys know trig so well. You just think to yourself, man, there's something that can help me out here. What is it? Sine of 2x, yeah, equals 2 sine x cosine x. Trig identity land. You remember that? You do now, though, right? So what do you end up with? What can you factor out to the front? 2, 0 to 1 of e to the u, and you're left with sine x cosine x times du over. What cancels? These are gone. What happens? What are you left with? 2, 0 to 1, e to the u sine x du. But what does u equal? So what can you rewrite it as? 2, 0 to 1 of e to the u du. Guess what you end up with? Same thing. Someone asked me before, why is it called u substitution? There's no good reason why it's called u substitution. Could you call it q substitution or r substitution? Yeah. Does it change the math? No. So yes, Camille, I think you ask a very good question. It gets a little confusing because we're using u in more than one place, but they're completely different u's. They're different u's, so you can use different ones. It doesn't matter what the variable name is. You can call it anything you want. You're acting the same forces upon just different labels. It's the same thing. So are they all equal? Do we have any idea what the actual areas are? No, but do we know that they're equal? We've taken it and said A, B, and C are all equal to E. So therefore A, B, and C must all equal E. They must all equal each other. They must all equal each other. Now, you might ask yourself, this doesn't look super complicated. How do you do this? In AB calculus, we actually do not, you're not required to know the method here to do this. You would need something called integration by parts. You now know U substitution, which is how you undo the chain rule. Anyone want to guess what what integration by parts allows you to undo? The product rule. You actually don't need that for AB calculus, so you don't have to. So we're going from 0 all the way to, let's say, that's an exaggeration, but there's 3. So what's the region we're looking at? We're looking at one region right there and another one right here. So you have two upper functions. You have this upper function, and then you have the purple upper function. Can you tell me what function is that one right there? That's y equals what? That's just x squared minus 4. But what's this one right here? Negative x squared minus 4. So you have two integrals now. Conveniently, you know that it crosses at 2. That's nice. So what's the first one equal to? This one right here. The integral from 0 to 2 of, what's the upper bound? Negative x squared minus 4 dx. And then you're adding 2 to 3 of x squared minus 4 dx. There it is. You just have to flip it over. What happens if you just do the integral from 0 to 3 of the original function and basically just ignore the absolute value sign? You're going to be adding up this bottom region right there. And what's the net change if it's below the x-axis? Negative or positive? It's going to be negative. So if you just did the integral from 0 to 3, you would end up with an answer which is way too small. You'd be taking things away. Here's the key. When you're working with absolute value integrals, make a picture, draw a picture, see what it looks like. Once you see what it looks like, it should help you come up with and set up the integral. Does that kind of make sense? Okay, here we go.